Okay, this is why we need the schematic, right? We need the see about the clock, about the crystal, um, about the external peripherals connected to the microcontroller, and for the initial port, the most important, besides that, the most important thing is the um, serial pins, the U art or use art. Oops, sorry, use art TX and RX pin. Okay. Okay. I think I think that is it. So, Lucas, is there is anything else that you remember about the schematics that is important?
I think that to this first part should be this, and isn't so important to this first part, but for example, the USB port, you use it to send the firmware using the DFO. So, but I think that this is the most important, Alan, for
Yeah.
this first step.
Okay.
Uh, and also we will port the LID pin, so it's important also to check which GPIO will be used for the GPIO, but it's okay.
Yeah.
It's
Good
on the
idea.
external peripherals.
Yeah. So let's put the uh, let's call it the programming pins, right?
Perfect.
The SWD or JTAG pins. Okay. So for this board, we have the schematic, right?
Yes.
Let me open it. Um, uh, Lucas, maybe if you can copy the,
I sent to you on Git chat.
it's here in the Git.
Yes,
Let me
on the chat.
find it. Oh, great. Copy and so for this board we have it here.
Yes, I will also paste at the YouTube chat.
Yeah, good idea.
Hey, Luke.
Oi, bom dia. Você tá me
Hello.
ouvindo?
Yeah, we
Let's
can
switch to
hear.
English.
Oh, okay, I'm sorry.
Bonjour.
English now.
Bonjour,
Mhm.
mon ami. Look. So, look, are you with the board? Everything's okay?
Yes, I just can't turn on my camera, but everything's okay.
Okay. If you can turn on later or to show the board, something like that is good. Rodrigo already uh, show his board, but don't you worry. Take your time. And so after this uh, first first step, we will start the porting itself. So what you need, what we need to do the port. The NuttX source code. Let me mute just a little bit. I'll mute the loop. Just a second. I will mute you. Okay. Thank you. So NuttX source code. In this case, we need the kernel https github.com/apache/NuttX, and we also need the application, the apps. Is similar link, github.com/apache NuttX apps. So, Rodrigo and Luke, do you guys already have the NuttX space like here, and the apps and the NuttX in the same directory? Did you clone it or not yet?
Yes, I called it.
Okay.
Yeah, I also have this.
Okay. So just to confirm, inside, for example, NuttX space or any other directory, you have apps and NuttX in the same place, in the same directory, right?
Yes.
Oh,
Yes, that's right.
that's right.
Yes, for
Good.
me too.
Perfect. So now we can enter inside NuttX, and if you already did something in the past, already use it, we'll start with the disk clean.
Okay.
This clean will clear the environment and remove all the previous binary objects. Okay. So let me do it from here. Okay. And
Are we going to show your terminal as well, or just the
I
presentation?
think,
Just to.
yeah, I think it's already in the live, but yes, I will enable it here.
Okay.
Yeah, I'll
No,
do.
that's okay. If
No, I'll do it here as well, because for you and to others to follow will be easier. Just a second. Sorry for my fault. Okay.
no problem.
Can you see now?
Yeah,
Perfect.
perfect.
Uh, Alison, everybody is also seeing in full screen in the YouTube, right?
Yes.
Oh, perfect. Thank you. So after the disk clean, we are with the pristine environment. So from now on, we can start the port itself. But let me just to make the documentation more complete. Let me share the document as again and write down it here. Okay. So sorry. to maximize it. Okay. So after cloning it, we need clear the environment. Actually, after cloning, we don't need to clear the first time because it's already clear. But
Alan,
yeah,
sorry to interrupt you, but we need to share your terminal.
yeah. I think I'm just writing here. I was writing down the configuration. Yeah,
Okay.
this is why I disabled the terminal. So clear the environment, and before we do any port, we have many approaches that we can follow. The easier way to do that, the easy approach, is just using based on a similar board. So use a similar board as starting point.
Alan, sorry again. Can you increase the size of the screen?
Yeah, I will do better. I will move it to other
Okay.
screen, and now it will be bigger in the YouTube, right?
Okay. Yeah.
So we will need a board with the same MCU or similar. In our case, we will use a similar because we don't have this exact microcontroller yet. So let's start to doing it, and I'll show in the terminal how to do that. Let me move it back to here. Okay. Stop sharing and let's share the terminal again. Okay. Good. The terminal is here again. And how we can do it? How we discover what board is similar to our? We enter inside boards, inside the architecture that we want to use. In this case, STM32 is an ARM microcontroller. And inside the ARM architecture, we have many microcontroller families. In our case, it is a STM32. So we will enter inside STM32, and here we have many boards for STM32. We need to find the board that is more similar to our board. So we type, let's move it, git grep STM32F401. If I try RC, there is no board. This, just to remember, I will enable the board here and let people see it. This is the board. Actually, it's a little bit difficult to read it because the camera resolution, but this microcontroller is a STM32F401RC T6. Correct, Lucas? Lucas, the guy who
Yes, it
created,
is.
yeah. Lucas is the creator of this board. He developed it to become a NuttX development board. Okay. So as you can see, when you search for this microcontroller, we don't have it. We don't have the RC microcontroller yet, or not a microcontroller on board using this microcontroller. So let me turn off the image of the board. And so let's see if we have, for example, any STM32F401 board, no matter what is the subfamily. Yes, we have one board here. This board is the Nucleo F4X1. This X here means it is supporting not only the F01, but also, for example, F411, 411, for example. But no problem, we can just start with this board as example. So what do we need to do now that we know the board that is very similar to our board? We just copy this board to a new name that we want to use. In our case, we'll copy it to STM32F401RC RS485, because this is the name of our board. Rodrigo and Luke, can you follow it? It's okay to you both to do this command here?
Yes,
Yes,
for me it's
I'm
okay.
typing.
Okay. Maybe I can try to, I don't know if it's possible to put this screen as a little bit bigger in the Jitsi. Let me see.
For me it's okay the size of the screen. Not
Yeah,
sure if it looks okay.
Yes.
For me too. Yeah, it's
yeah,
cool.
it's possible
I
to
can
see.
read it.
Oh, perfect. So let's keep this way. One very important note here, take care when you are when you are copying this name, because if you, for example, uh, miss some letter, or if you change anything, it will not work later. So this step is very important. All steps we need to pay attention, of course, but uh, the name of the board is very important, because uh, when we are lowercase, we use this approach with the dash, and when they are using for example, uh, the symbol name in uppercase will replace the dash with the underscore, because the the dash when you use it in the symbol could generate some issues. For example, you cannot use it in a C symbol, because it will represent the minus. So here we use the dash for the director name, but later in uppercase we will use underscore. Okay, it's very fast, just copy some files, and now we can enter inside our board STM32F401RC RS85. Okay, inside this board we have the CMake list, the configs, the include, the kconfig, the scripts, and the SRC, where is the source code. So the first step here will be change the script inside, sorry, not the script, the header file inside include. If you see inside include, there is a board.h, a nucleo F01RE, and a nucleo F401RE.h. If we open, you can, for example, if not familiar with the VI, you can, or you can use a graphical editor or even Nano, for example. But I will show in Nano here. So here we need to change the name. It's not mandatory, but it is good because when you are submitting the source code to mainline, we need to use the right name. So we need to replace here with our board name. Yeah, just keep this way. And here as well, we'll change the name to FRC. Note now I'm not using the dash here. I am already using the underscore, right? Okay. Now there is an important thing. As you can see, the test here is for STM32F401RE. Our board is not RE, it's RC, okay? So we need to change it here. And also here, we'll change we have two options here. We just change the board name and put it as the STM32F401RC, sorry, together here, RCRS485, and remove this one that we don't have. Or because it's just include, we can copy the content of this external file that was the nucleo F401.h and copy the content here. But I will show one trick. Many of you that are familiar with Linux know about it. And I will save. So we can remove the board we are not using, the 11, for 11. And now we have board.h and nucleo F401RE.h in the same directory. As you remember, inside board we are including this nucleo F401RE.h. So how we can copy this nucleo to inside this board to that place? Actually not exactly that place, but we can just copy the content of board.h to the end of the nucleo, the F401. We can do it, for example, using cats nucleo.h, the symbol greater than 2 times. Oh, sorry, it's the opposite, right? I need to copy board.h to the end of the nucleo, because the nucleo, the content of the nucleo need to start before the content of board.h. So we use cat board.h to nucleo. Rodrigo, did you understand what I did here?
So you are appending the
Yeah, yeah.
uh,
Your audio is cutting a little bit, but exactly that. I am pending the content of board.h to the nucleo F1. So
okay.
yeah, if I open now, sorry, I will use VI. Uh, I cannot
Okay.
use Nano too much, but I don't like Nano. But if you see, I have the the nucleo content here, and after that, we see we have the board.h here. What I need to do is just copy the header, move this header to the beginning, right? Because this header is the header that we already modified. So I
Sorry, Alan, did you include the end the let me see.
yeah, I append it. I append board.
Okay.
Yeah, I
Okay.
append the board.h at the end of the nucleo, right? Because the nucleo need to start early, but now I am converting these both files in a single one. Now the new file will be the old board.h, but it's still the nucleo name, right? Because I just append it in the end. So I can just come here and remove this nucleo.h information that we don't need anymore. The this part here, okay. And so we start with the nucleo information, and now we can just rename it to STM32F, or let's call it this way. Yeah, note, because it was the nucleo board, it says that the nucleo board doesn't come with a crystal. So it is using not the external crystal, it is using the internal oscillator, the high-speed internal oscillator. This this is why the symbol here is 1. And the internal oscillator is 16 megahertz, okay? Uh, Rodrigo, I think it's a little bit confused that way I did. I append and I am modifying. Later, I will show um, a simple example, just copying a board.h that is already configured to use this 8 megahertz clock that we have here in our board. Look, here we have this crystal. Look in your board. What is the frequency in this crystal that is right in your board?
Oh,
Can you see, or is too small?
Let me try. Dot
Here, I think
3.1.
it's yeah. You can say
It's
first.
8 megahertz. 8,
Yeah, here it says 8,000.
8,000.
Oh, okay. Now I see. Sorry.
Yeah,
Thank you.
exactly that. 8 megahertz, 8,000. Thank you, Luke. So, uh, just to explain, in this case here, we are not using this crystal, right? Because we are using the internal uh, resistor capacitor or RC oscillator. And the internal oscillator is not 8 megahertz, it's 16. So let's do this way initially, and later we'll replace all this file with a file from other board, a similar board that already using the 8 megahertz external clock. Because this configuration for 16 megahertz internally also will work. So we don't need to care about it. And now we can,
Sorry, I wasn't able to follow the last instruction,
uh,
like the last modifications.
you mean copying the file, right? The header.
No, this was okay. After you copied the header, I was a bit confused.
Ah, okay. After I um, after I copy this header to the beginning, I just move down and remove the header of the nuclear board. Do you see? It's very similar to this license message, but instead of having this one, it has nucleo .h, nucleo F401.h. Did you find it? It is just here, just in the beginning.
Yes, so replace the one in the beginning with the one we copied, right?
Yes. Some just replace and you have this one. Can you see it? Board,
Yes,
arm.
I got it now. Yes.
Okay, I think someone has a catch.
Give 30 seconds, Alan. I think I did something wrong here. Let me
Right.
fix that. So,
If you want to share your screen, let me stop
okay.
my sharing.
Just check. Let me try here. So share my screen. Okay. Okay. Sorry.
No problem.
Can you see now? Yeah. Okay.
Yes, yes.
So I think I did something wrong because the if def here in the top of the file is still the other board. So I think this needs to be removed, right?
Yeah, you remove it and use the last one that is in the bottom.
Yeah. I think that's the okay.
Yeah,
So this
that
one
part.
here, right?
Yes, yes,
And the
So we copied the whole thing from the board file to the top now, right? The whole content,
the only the header, right?
only the header.
Yeah. The, if you see after the header and this if def, this other part include files and so on, it will repeat, right?
okay.
Yes.
So Rodrigo, so just copy these two lines, the
Okay.
yeah, and put it after the header message.
Okay, so here. Okay. And how about the other part of the file? Do I need to remove that?
Yeah, now let's follow
So
from
so
your to
from
help.
here.
Yeah, here you need now to remove these ngifs because we don't want to finish the
Okay.
configuration from here. We need to continue.
Okay, so remove these two lines, right?
You don't need to move because there is already an ngif in the bottom. If you go to the bottom of the board, you see there is already two ngif there. Go to there. Let, let's see.
Okay.
Yeah,
Okay.
see,
This
there
one.
is an ngif. So you can remove that ngif in the beginning, in the middle. Let's put this way.
Okay.
Just to confirm, we removed the assembly and the boards, ARM, STM, these two and ifs, right?
Yeah, like in this file from Rodrigo. So Rodrigo,
So I
you need to
uh-huh.
remove this ngif assembly and this.
Okay. This one. Oh, sorry.
Yeah,
And this one, right?
no. The
No, I think they're after public function
Yeah,
prototypes.
you are in the bottom. Just undo what you are doing and move a little bit to up.
Okay.
Yeah.
Okay, just a second. There's something wrong here.
Uh, I think undo is Control U. I don't use no.
I'm
No, no,
I
sorry.
did I didn't use this one as well. Okay,
Yeah.
so
So
I
move
can
up.
get this one here and put this one here. Okay.
Yeah, move up. Let's see.
Okay.
Yeah,
Yeah.
let's to start from beginning again.
Okay.
So okay. Um, yeah, this is where our board starts, right?
Okay.
And after that we have the include files that include only NuttX config or stdin.h if assembly is defined. That's perfect.
Okay.
So as you see, assembly is already defined here. So that line that including in the middle of the file we can remove. So let's
Okay.
move to the middle because this is the initial part. Yes, this one.
So these include files here. I can remove here, right? This one here.
Even a little bit higher than that, you can remove the external C++ and so on because
Okay. Let me know.
yeah, I think after public data, uh,
Oh,
uh,
now from here.
yeah, I need to verify. Just a second. I'm not.
Okay. No
Uh,
problem.
I need to confirm because I need to remember if it's from the previous file.
Yeah, sorry, my mess.
No, don't. It's my. Uh, it's not your fault because I decided to do this way just to annex, just to merge two files to concatenate the files. But actually, it's not so easy doing this way. So um, how can I do? How can I do it? Let's see. I have an idea. Remember, I said we have a board already with the right configuration that we need.
Okay.
I will I'll share my screen again.
So I stop here.
Yeah.
Okay.
So, Rodrigo, I will open my file now and let's follow. Is already shared? Can you or not yet?
Yeah, I'm seeing
Okay.
your file. Okay.
So
Let me compare.
yeah,
Okay.
let's see. First we have the if defs. Then we
Okay.
have the include files, right?
Okay.
We have the preprocessor. So we are moving down.
Okay.
And then we have again here public data, public functions,
Okay.
and so here we finish the board, right? This
Okay.
part,
So
let's find the same part here. Did you find public data?
the public function prototype.
You are in the same page, right? Here, right? Public data.
Yeah.
Perfect.
That's right.
So if we move down
Okay.
until the end, we see we have okay, we have the NDIF of the previous board. This this board.
That's
Go
the
to
same here.
yeah, go to the bottom and let just to avoid to avoid confusion, let's rename it already to RC RS 485. Okay.
Okay.
Now we can move up.
Just a second, please.
Not up, sorry. We can move to the middle. And here we are in the same place that was in the original board.h. Probably we already remove it, correct?
Yes.
Right.
I get this part put in the top of the file, right?
Exactly.
Okay.
Yeah. So here we just need to remove this NDIF here, the board, ARM, STM32, Nucleo, that already exists in the end of the file, correct? Remember, I just rename it that it was in the bottom. Uh, are you in the same page, Rodrigo? Did you have this public function prototype?
Uh,
It's,
yes.
yeah, it's in the
Yes.
middle. Are you in the same?
Yeah.
Your board, your file is like mine now, right? Public,
That's right.
external,
Okay. So
and two NGIF, correct? NGIF assembly and NGIF boards.
yes, I found now. So
Okay.
just need to remove these two, right?
No, only this one. Sorry, I said two
The
before. Only this
okay.
last one, this board army. Remove it
Okay.
like I did. Okay.
Okay. Perfect.
This one probably you already removed this board and so on. I will remove it. And also this this definition here from the old board we already removed because it is in the top. Let's go to the top to confirm. See? Oh, sorry. It's not. I thought I already copied that, but yeah, I will just. I think you and Luke
Difference.
already did it, but
Yeah.
let me do it. Okay, now we have the defines, and we can go back to
So
that.
just let just to compare the files, right? So go to the top, please, Alan.
Yeah, I'm returned to there. So
Okay.
after here, after prototype, we have this uh, this ngif assembly, correct? Can you see it? Function prototype, public function prototype. Can you find it?
Okay, it's in the middle of the file
The middle
again.
of the file.
Okay, going to there. Okay, if
Look,
not,
Loki, did you find it as well?
Yes, I
Okay.
did.
So here in the middle, we'll do, we'll remove the include file, this line, and also this one because we already have it there. And see, now we come to the place where the above file was included. Remember, I said, we can include this file here or we can copy it. We decide just to copy, correct? So
okay,
as we copy, we don't need to include it anymore because this clocking configuration is already here. See, frequency,
mhm,
clocky, can you see?
okay,
Do you understand now what I did? I just copied the content of the clock, the external header, to the beginning of the board.h, correct? Now I'm, I think now we are done. Uh, just, I'll go back to the middle just to confirm that uh, you and Luke have the same configuration. Okay? Uh, After public function prototype, we will remove these include lines and we will have just uh, NDIF assembly and the preprocessor definition.
Mine is the same.
It's the same. Rodrigo, is yours the same? Is yours the same?
uh, pub, public data.
Oh, let's show.
Okay,
Public
okay, I
data,
have,
yeah.
uh, mine is the same as well.
Oh, perfect. Public data, if not def assembly, we include this external C, we ngif here, just to confirm one by one, if, else, ngif. If not that assembly, mm, correct. If this if is from diff and as in diff assembly from this above in diff assembly. Did you see here? Or see, if not that assembly and diff assembly, okay? If defined C++, else, and diff C++. So this block already closed here. And if defined C++, close the brace and put in diff. So this block is closed correctly as well. Now we can uh, save and exit, okay? And because we transform the Nucleo F401RC.h in the board, now we just move it to the board.h,
Oh,
okay? Did you move it? Did you rename?
Yes.
If you see now, we have only the board.h because we moved the nucleo F401RE.h to board.h. If we open it again, you see it's our board.h. So, but it's still with the previous name. We need to rename here F41RC RS485, and here the name is board.h. Okay, I think it's correct. If it's not correct, we will see during the compilation. I hope we don't see it. Okay, so
Let's
we already created our clock configuration. What we need to do now? Now we can enter inside scripts. Here in scripts, we have the same thing. We have the F401 and the F411. We don't need the 411, so we can remove it. Okay, and we can just rename this F401RE to a simple name, a simple link script name. The full link script name normally is LD script. So let's rename it to LD script.
Okay.
Now we have LD script and we have make.devs. Let's open the LD script and let's do some statics here. So put the right name in the file. And here's the most important thing. Our chip, our microcontroller is not F401RE, is RC. The RC has only 128 kilobytes of flash, and it has only 64 kilobytes. Okay, and here in the memory we do the same. We change it to 1 to 80 kilobyte and 64. Okay, Rodrigo and Luke, did you follow?
Yeah.
Okay, the remaining is okay. We don't need to do anything else. We can exit. Now we need to modify the make.dev. Same thing, we rename it to STM32F401RC RS485, and here we need to change. We don't need the F411 as well, so we just remember to remove this line
just a second.
and this line. Sorry.
Just a second, please.
Right. And we need to
here.
rename our link LED script. It is now called LED.script. And here we need to change the microcontroller name or microcontroller symbol, because it's not RE, it's RC.
Just a second, please.
Okay.
So script
Uh,
RC.
yeah, it's important these three lines be exactly as here.
Mm, okay, I'm okay. Yeah.
Okay, look,
I'm okay too. Yeah, I'm okay.
it's okay. So let's see, we don't need to change anything else here. Correct. We can exit. So we are done here. Now let's see each other file we can change. Let's modify now the CMake list as usual. As usual, we just change the name. Anything else we don't need to change. So it will only static is here.
Sorry, I lost the file. It's the main CMake file.
The CMake file,
Okay.
this name CMake list.txt. Did you find it? I need to go back. After
Yes, in the
I
main folder, right? Yeah.
yeah, I
Okay, I found
return from previous folder. I left the script and modify in the here where you have CMake list, configs, include, kconfig, and scripts and src. I I modify this file. Actually, it's only static. It's just the name of the file. If you don't do it, uh, anything bad will happen. So it's not problematic here. Okay. Now will modify this kconfig. It's very simple as well. We don't need these configurations here because we are doing a very basic port. So we are not interested in quadrature encoder and joystick or anything else. So we just remove, and here remember it's not RE, it is RC. Okay, Rodrigo and Luke, did you did you did the same modifications?
Yeah.
I'm sorry,
Yes.
there is something wrong here. What I did wrong?
The board name.
You
I keep
no, you forgot
the
to take the Nucleo name. It's not
yeah.
Nucleo.
What is the name? STM32F401RC underscore. Here we cannot use dash, so underscore RS 485. It's the same here, board STM32F401RC underscore RS. Okay. Uh, Now, Rodrigo and Luke, did you write the same name?
I'll just a typo here. Yeah.
Yeah, mine too.
You both are okay?
Yeah.
So
Yes.
let's move on. Okay, finally, in this root directory, we did everything we need to do. Now we can go to source. In source, we have many files. We don't need these files for initial port. Each files we don't need. Well, we don't need analog digital converter, so we can remove it. We don't need analog joystick, we can remove it. And we don't initially we will not support the buttons as well because we have only uh, the serial port console and the the LED to indicate the board is turned on. The NuttX is started. So we'll remove this one. Also, we don't need LCD because this board doesn't have an LCD connected. Of course, in the future, all these files probably will include back because we want to use LED, LCD, we want to use uh, analog to digital converted, and so on. So let's remove we also will remove this MCP 2515. It's a SPI CAN bus. We don't need it. Also, we will not support initially SPI, so we can remove it. And also, we don't will use user-led support. We also remove it. But I said we will have LED, you have LED to indicate the board, the NuttX is turned on. Why I am removing this user LED? It is because user LED used to let our application to control some LEDs. In our case, uh, for the diagnostic LEDs, diagnostic LEDs, we use this file auto LEDs, auto LEDs. Sorry. Okay, uh, Rodrigo and Luke, did you remove all these files?
Yes.
Yes.
So now let's count how many files we have. We still have. Rodrigo, and how many files
7.
with
I have 7.
7? And Rodrigo,
Yeah, seven.
7?
Yes, same here.
Okay. Did you see we still with the wrong board name? We need to rename it, correct?
Okay.
So let's move it to STM32F401RC. Here we use the dash. We use the same name of the board name, right? Dot H. And now we have say make list, make.def, STM32 app init, auto LEDs, STM32 boot, STM32 bring up, and our board name STM32F401RC dash RS485.h. Okay, everybody did it. It's okay, Luke. It's okay, Rodrigo.
Yes.
Yes, from my side. Yeah.
Okay, so we can start modifying all the files. So open this make list. Here we need to remove the files that we physically remove from the disk. So we need to remove STM32 SPI. We don't have LCD, so we'll remove this line. We have ARC LCD, ARC LEDs, diagnostic LEDs, diagnostic LEDs, correct? This file. But we don't have anymore the user LEDs, the user LEDs. So we remove this else and this list. So we have only the STM32 auto LEDs.c. Here in the buttons, we also remove the buttons file. We don't need it. We also remove the ADC. We don't need it. Also remove the SPI CAN bus chip. So we remove it. And this one is okay. We have it. Config board control will include the STM appinit.c. And here we have more modifications to do related to the chip family. It's not RE, it is RC, correct?
Okay.
And here we can remove these L's and this F411 chip that we are not using because it was for a different board. So we remove this one. We need to do one more thing here. Remember, we renamed this file, the F401RE dot LED, the link script file. What was the name of the file inside the script?
LD, right? Script.
LED
LD.script.
LD dot script. Very good. It's script or scripts? I don't remember. Yeah, I think it's script.
I think it's script, yeah.
Yeah, perfect. Okay, Rodrigo and Luke, please confirm your files are similar to
Yes,
this
it's
one.
exactly the same.
Okay,
Yeah.
so we can
I
save and next. Now we can modify the make.def is a make file similar to cmake file because NuttX support make and cmake. So it's basically the same modification we did, just different naming. So we remove it here. We remove here. The LED, we keep only the auto LED. Remove buttons. Remove ADC. Remove SPI CAN bus. Keep this one. And in this case, here we don't have the link script because the link script is used in that make.def that was inside the script directory. So we don't have it here. Rodrigo and Luke, did you get it? Did you remove
Yes.
and keep
Yeah.
just these files?
Yeah.
Okay.
But-
You say you're going to say anything?
No, I said it's okay
Okay.
from my side. Is my microphone okay or?
It's okay now. It's not
Okay.
cutting. It's very good now. I think your
Okay.
internet is better or the microphone. So now we can move to the next file, STM32 AppNet. Here we just change the board name just to keep the right information.
The last file we forgot to.
I will. So I will. The
I did
STM32
it.
appnet.c. Okay. Open this file. Rename the board name to F41RC 485.
In fact, I want to say that in the last file that we edited, we forgot to check the name. Not this one, the CMake file, I think.
Make.dev.
Yeah. So open this one.
Good.
Go to the header. I think we forgot to change the name, right? The header.
Oh, you are right. My mistake.
No problem.
Okay, very good. You are paying attention. It's good. Yeah. So now we are back to the appnet, STM32 appnet.c. Let's see, we need to do something here. Yeah, we need to change the board name of the header include. Our board name header file is F01RC RS485. And Let's see. Anything else to change? No. So just change the header name here and the header file inclusion. Okay, to STM32F401RC-RS485. Okay.
Okay.
Can I finish? Can I will save and quit. And now we need to change the auto LEDs. Lucas, do you have the schematics of the board open in your side?
I can open just a second.
Yeah, I think because we want to see what is the what is the um, what is the pin used to the LED one. So if you
Okay,
can open and share it, I will stop sharing my screen because
okay.
we will need it.
LD1 is
Please share your
the
screen to,
PC0.
yeah, share your screen to, okay.
Yes, I'm sharing
W- Where is the LED one? Sorry, I didn't.
here.
Okay, is the uh, port C pin 0 or PC 0, right?
Yes,
Perfect.
perfect.
Thank you. So I will return to sharing my screen. Oops. What what uh, what what's going on? Okay, I see now. Okay, now you can see the my screen again, my
Yes.
terminal.
Yes.
Yes.
Okay, so let's change the STM F the header name, and here as well we need to change the board name STM32F401RC RS485. Rodrigo and Luke, did you already change the names?
Yeah.
Yes.
Oh, perfect. So uh, we are not use the LED2, LED2. We use the LED1. So let's call it GPIO LED1, correct? Here as well, LED1, and here as well, GPIO LED1. We'll define this pin. We'll define GPIO LED1 is the port C 0 or PC 0. Okay. Um,
Just a second.
did you change everything? Change the header here, the board include
Just
name, and the
a second.
LEDs, the LED pin to
Yeah.
GPIO LED1. Rodrigo and
No,
Luke,
Yes. Okay.
yeah,
yes. Now I'm okay.
okay, so we can close, and now we can open our STM32F401RC header file, and here let's let's move to let's change the name as well, STM32F4RC RS485, and here as well STM32F401RC .h. Okay. Here we also need to change the board name, and Nucleo become Nucleo FR F401RE become STM32F4RC underscore RS485. Same here. Underscore RS485. And the final name as well after the search.
So
It's just static, but it's a good idea to change the name.
but so in the end of the if and f, there is the okay, yeah, just double check. So
Yeah, in the end of the file also has a if def with the name that we need to change as well.
okay, so just a second, please.
Yeah.
I need to.
Actually, we could remove many things here, but for now, I just want to change the LED number. The GPIO LED2 will be called GPIO LED1.
Alan,
Yes,
sorry for that, but could you go back in the def? If I lost this one, you
this one.
the if def, yeah. So you double the name, right? So
Yeah,
okay.
because the original name, it's if you pay attention here, it's a sequence of directories: boards, ARM, STM32, STM32F01RC, RS45 with the board name, slash underscore by representing slash, sus, STM32F4 401RC underscore RS 485 underscore H. It's just a representation of they are representing the director sequence. It's just to avoid have two boards, for example, with the same defined symbol. Understood the
I
idea?
see.
It, it's similar to Pragma when you use to avoid include be used twice or two times. For example, if some other file try to include it again, it will not be possible because this the first time it will be included, it will define here this symbol. So the next file to include it will fail because the symbol is already defined here. Okay?
Mm-hmm.
It,
Okay.
it is just to avoid including twice and make issues. Okay,
Okay.
so after that, we just need to modify the GPIO LED2 to GPIO LED1. And here we change the port to the name that Lucas told us that is the board. The board LED is the port C or port C pin 0 or PC0. The remain is still the same. Okay,
Okay.
Lucas as well. Sorry, Lucky.
Yeah. Okay.
Lucky. So you already changed port C and pin 0, right?
Yes.
Okay, good. So in the bottom of the file, there is only on cosmetic as well, the previous name, the nucleo. If you want, but it's just a comment, so if you don't change it here, no problem as well. But let's change it just for make things more clear. Okay, perfect. Okay, did you guys already change it?
Yeah.
Okay, so
Yes.
let's close. And okay, before change the header file, we are change the auto LEDs. Let's see what is after auto LEDs. Is the boot.c. So let's open it and see if we have something to change there besides the name, of course, the board name. STM32F401RC. Okay. And here in the header, we need to change as well STM32F4RC RS485. And let's move down if there's something. Okay, auto LEDs will be initialized, correct? As you remember, I'm not adding support initially to SPI, so I'll remove SPI. And also, we are not adding support to USB, so we'll remove USB from here. And we'll keep the board initialized only with the auto LEDs initialized, just to indicate to turn on the LED when the NuttX starts. Okay? And here we don't need to change anything. So just change the board name, the header includes, and here. Did it?
Yes.
Okay. Remember
Yes.
also to change here the includer.
Should we remove the include for the SPI.h?
Yeah. You can remove it here as well. Right. Good point. Yeah. I forgot to remove. Since we are not using it here, we don't need to use it. Okay. So we can save and quit. And finally, the last header to modify is the bringup.c. Same thing here, change the board name, STM32F401RC RS485. And let's see. There are many things here we are not using, for example, SDIO, MMCSD that are used for SD card. Also, user LEDs we can remove, and we'll change the board name. STM board name header file RC RS485. By the way, Lucas, I didn't ask you, but are you writing the file as well?
Yes.
So you are following us as well, right?
Yes. I actually changed all the names before.
Sorry, Luke. I was asking if the Lucas.
Yes.
Okay. Because I'm only asking Luke and Rodrigo, but I forget to ask if you are following as well.
No, don't worry.
Okay.
Go on.
So let's remove the encoder because we are not using encoder. These have LEDs here is also used to user LEDs, so we can remove as well. And also remove the LEDs path, user LEDs path. So we'll keep it very clean. We just need the UART and the board name.
Okay.
Okay, and moving down, here have LEDs to register user LED, we can remove. Also, we can remove SPI because we are not initializing SPI. Also, LCD, we are not using LCD. Same to frame buffer, same to SPI CAN bus, same to SD card. It's a little bit sad because in the future we need to add everything else again. But I think it's important to show that you don't need many files to many modifications to get the board initializing. If you see later, all all board files have basically only the function's name and the very basic to let the board initialize. For example, see the bring up is not doing anything. It's just return OK. I even don't need to include this variable here if I don't want. I can remove it and just return OK, for example. But let's keep it this way because in the future we can use it. Can I say? Can I quit and save?
Yes.
Okay. Rodrigo as well.
Yes.
So guys, we finish modifying these header file, these source files. Now we need to create the board config. So we will return 1, 2, 3, 4 directories, and here inside NuttX boards we need to open the kconfig. Rodrigo and Luke, are you in the board in NuttX boards?
Yeah.
So let's open this file.
Yes.
Okay, let's move to the beginning. Do you remember we are using the Nucleo F401 as example? So let's search this board definition here, STM32F401, this one, okay? We find the board we are using as example here. What we are going to do is we'll copy the same block to create a new entry to our board. So I will copy it and paste here, and I will change the name. Now the name is STM32F401RC underscore RS485, and he will do the same. RC, he's just the board of the name of the board, sorry, 485 board. And remember the chip.
But-
Sorry.
Just a second, Alan.
Mhm.
This board
Your audio is cutting, Rodrigo.
Okay, so let me try to change my font. Sorry for that.
No, it's okay now.
Okay, so the board name that you okay. Just a second, please.
Yeah, it's just the symbol to define the name of the board. Our board, we copy the Nucleo. See, the block is very similar, but now we are changing it to a new board name. So the symbol that will define our board will be arc board STM32F401RC underscore RS 485. Understood, Rodrigo?
Yes, but just a second, please.
Okay.
Let me try to
Yeah.
catch up where you are now. Just
Yeah.
a second.
So, okay, maybe because you didn't find this block yet, right?
Yeah,
Yeah, you
just a
need to
second.
go. It is about 35% of the file. So you need to. Uh,
It's line 1582.
yeah, yes. This is the number. See, this is
Okay.
the
Now
position.
I
1500.
Yeah.
thanks, guys. Now I found that. Let me just catch up
Yes.
with what you already did.
You need to
Sorry.
copy this block. This 1, 2, 3, 4, 5, 6, 7, 8, 9 lines, and paste it, for example, just after the initial block. Okay.
Okay.
Now we need also change the ship the arc ship version or model is not RE, it's RC. So this name need to be RC. Remember, if we don't want to use buttons and so on, we can also remove it. But for now, let's keep it here because it make no difference. It's just saying that our board has buttons, has LEDs, and have buttons with interrupters and so on. In this case, um, it's true because our board has these functions. We are not supporting it in the initial version, but it's okay. We can keep it this way. And now, here in the comment, we change the board name. Instead of nucleo, say F41RC RS485. Okay?
Okay.
Now we need to move down. I will find the nest. Okay. Sorry, it's not. It's the F. Oops. What is the nucleo? This is the name I need to search. F10RE. Okay. Now you need to move to the line 3139 is here, where the nucleo board name is defined. Is a very long line, so I will copy this line and put it after that as again and rename it. This name here need to be the name of our director or the name of we are using STM32 F401 RC dash RS 485. If you do it incorrectly, the build system will not be able to find the board. So pay attention at this position, at this name, at this position. And here we need to change the board name as well. It also need to be the same name. And here we use underscore. Okay?
Just a second.
Did you find the line?
Yeah. Just need to remove this from here. See. I'm okay.
Okay, Luke as well.
Just a second, just writing up the last line.
Mhm. Yeah, you need to pay attention. These lines need to be exactly like here. STM32F401RC dash RS485 if artboard STM32F401RC underscore RS485. Okay?
Okay, I'm finished.
Now we need to do the last modification. There are three places in this file that we want to modify. We already modified two, and now we are going to modify the last one. Here, we copy again. We will copy three lines, these three lines, and paste it after the block. So here we change the board name STM32F401RC underscore RS4A5. And here we need to point to the right kconfig STM32F401RC dash RS485. It is the at the line 3,855.
Okay, I found it.
Mm-hmm. So again, you need to copy these three lines here, this, and this. Copy after this block, so you have the three line again, and then you modify it to artboard STM32F401RC underscore RS485, and also change the board name to STM32F401RC RS485 kconfig.
Okay, I'm
Okay,
okay.
you both.
Yes, I'm okay too.
So let's close and save and close. Now we need to go back to ARM STM32, STM3281, RC, RS. Here we need to enter inside configs, and first we need to remove the configs we are not going to use. So rm dash rf f401 fb frame buffer, also f11 asterisk, we need to remove all, so we'll keep only with this last one. And because we don't have two two board models, we just move it to other name. Let's call it just NSH, because it will be easier to configure later. So now inside config we have NSH. Okay.
Just a second, please.
Mm-hmm.
Ah, no. Okay, so remove this one here, remove this one here. Okay. And now move this forward. Okay.
Okay, you have NSH now.
Oh, just a second.
Yeah, the NSH need to be from the F401 NSH, right?
Could you go back to one folder and do a list to so I can compare my files?
Mm-hmm.
Okay, that's okay. So now config we just have the NSH, right?
Yes, yes, yes.
Okay, so I'm okay now. Sorry.
No problem. Enter inside NSH. You see we have a def config. We will modify it with the board name that we just created. Um, Here, the config artboard is the name of our board directory, STM32F401RC RS4A5. And here as well, the board name changed to STM32F401RC underscore RS485. It's correct? Okay. And here, remember, our chip architecture is not STM32F401RE. It's STM32F401RC. And that is it. Three places that we need to change. I'm looking in the bottom. Yeah. Yeah. Okay.
So the UART to be used for serial console will be the UART2. Is that okay?
Yeah. Good question. I don't know yet.
Okay.
Lucas, do you have the schematics easily to show us?
Yes, let's share. I
Just.
don't know, the screen isn't showing for me. Just a second.
Mm-hmm. We are in the.
Okay, now, okay. It's here.
Oh, perfect.
And okay, which UART will be used, Alan?
Yeah,
21?
I think to use that one that the label uh in the header pins. Where this one, yeah, the pin use
PA.
R2TX and use R2RX. So Rodrigo,
Ah,
about your question here in the
Okay.
CN4, the header pins, yeah, yeah, the 18 and 20. So, Rodrigo, about your question, yes, let's use WART2, so we don't need to change these pins, okay? Thank you very much,
Great.
Lucas. Okay, so I will share again. Can you see my screen?
yes.
I need to do something. It's gonna take 5 minutes. We take a short break?
Yeah,
Just a second.
we can wait you.
Okay, thank you.
You're welcome,
I'll be right back.
right? And so, Rodrigo, while look, go out and return, let you pass again just to confirm. Did you change the board name, the artboard to STM32F401RC,
Yes, that's okay here. And
RS485, also the artboard STM32F401RC underscore RS485, right?
yeah, that's right.
Yeah, and because you asked about the about uh, the UART pins, let to confirm
Okay,
we are using the right pins for the UART2. Okay, uh,
great.
Lucas, what was the pins used to UARTX and RTOS?
Let me check out together.
Okay,
It is TX. It is the PA2,
PA2,
and RX. It is PA3.
PA3. Okay, so Rodrigo,
Yeah,
let you go back two directors to be in the
okay.
same board director. Let enter inside include. Remember you have a board.h that was very complicated to create because
Yeah,
I buried it too.
that's
Let's
okay.
see
Okay,
let's see if you have the definition about the UART2 here. It needs to be here because normally the NuttX use the board.h to define the pins about the watch.
okay,
Let's search here, okay. Is in the UART1, okay. The UART1 is to P810 and P89, okay. We are not worried about UART1 because we are using UART2 to serial console. And here we have, see, it's already
okay.
configured to P83 and P82. Lucas, just to confirm, GPIO
Three.
what?
PIO3 it is reception, and PIO
Perfect.
PA2 it is transmission.
Yes, perfect. So, Rodrigo, it's already correct.
Yes.
So we can go back
Okay.
to configs, NSH, and just to confirm that Luke is already here. Luke, did you return or?
I think not yet.
Yeah, I think he's still. Uh,
Uh, uh, I asked just while Luke
mm,
come back. I asked about the UART because I was trying to play with this board here. Not sure if you can see. Is a
are you sharing? No,
STM30.
no, not yet.
It's in my camera. Oh, so I need to.
Yeah, I need to share
Uh,
and let me.
Hi, I'm back.
Oh, perfect.
okay.
Uh,
Okay, we can talk later about it. But I was trying to play with one of the STM32L4 boards, and
Rodrigo, it's up to you. If you want to share, we still have time. What? Please share your screen and show what your question.
let me. I think we can continue and do this in the end, Alan, because uh, I need to. I'm not prepared to share now right now. I need to open the file and show you
Okay,
the question. I need to formulate my question, to be honest.
right, right. No, no problem at
Sorry
all.
for that.
Okay, look. Did you change these three places here, here, and here? Look,
Yes, I changed the three places.
so we can save and quit.
Okay.
Now, if everything is correct, we can finally try to compile our first board supported
Oh,
by ourselves and NuttX. So let's return 1, 2, 3, 4,
Now,
5.
now, now it's now it's time to see how many typos I did, right?
Or we all did because this kind of port need to to have a lot of details, and yeah, we need to return 1, 2, 3, 4 directories to return to root of the NuttX. Okay, everybody's here in the root of the NuttX.
Yeah.
Okay,
Yes.
perfect. So I hope everybody pray a lot because now is the moment of the truth. Just before I run the config, let you double check everybody has the unknown ABI GCC installed.
I don't.
I don't believe it. You don't?
I'm sorry, I didn't see. Wait, just a second.
Okay. What system are you using? Are you using Ubuntu?
Yes, it's installed. I'm sorry, I just didn't know.
Okay. Yeah. So you type it. You type GCC, and you see everything here, right? You see?
Yes, I see everything.
Okay, perfect. So guys, let's clear screen, and to configure our board, we need to know the name of the board. So what's the name of our board? I already forget. Let's see. Oh, it is the STM32F401RC RS485, correct? So what the board configs I have to this board? I have only the NSH. So to configure this board, I need to use tools configure.sh STM32. Now I am copying the name of the board. To avoid mistakes, let you copy here and paste it here. And after the name of the board, I need to put the board profile I want to use. Because I have only one, only the NSH, it will be NSH. And I press enter. Oh, there is already a mistake. In my board kconfig, I put ANSI in the name of the board. I think it is lipped and I didn't see that. So it is easy to fix.
I have no errors.
Oh,
Mine's
good.
good.
And Rodrigo?
No,
No errors?
too. Yeah.
Oh, you are better than me. I did a mistake. So let's try again. Oh, I know my mistake now. Yeah. I don't know why, but I keep the name. Did you? I hope you didn't do it right here. Yeah, I know. It removed for some reason the config. Maybe some command I did. Oh my gosh, it's not that. It changed the nuclear board name, but no problem. I will fix it in a second. Arc board nucleo. Now it's okay. Yeah, I missed it. I think while I was copying, I modified this name here for some reason, but okay, now it's perfect. And try again. Perfect, finally. Sorry for this interruption, for this
No
uh,
problem at all.
fault, but okay. So
It's okay.
we configure correctly. Now, the most important part. Now we need to run make. If we did
Yeah.
some mistakes, we will see it now. Some other mistake in my case. Actually, to compile fast, I can use make is space dash j, but I don't want to do it because I want to see all files being compiled and see if it compiled correctly. Oh, it's just okay. It's just a warning, but it's because we are using the legacy thing. But okay,
My finished correctly.
mine
Hmm.
also true. And Rodrigo?
No, is stuck in the, I think, register sh.
Ah, okay,
Just
no,
in the beginning.
don't worry. Maybe it's still compiled. Are you using some virtual machine or something like that?
No, no. But part is that the, you see the register dot sh, then there is the cc and the, you can see the files being compiled. I didn't uh,
Well, strange. But maybe it just I don't know. Maybe it's still processing or it.
oh, now it started. Yeah,
Maybe
now it started.
you are using an old
Just
machine. Yeah,
in fact, it's not.
not
Let's
old.
see.
Yeah, maybe some other more priority process is consume your computer processing time.
Or maybe it's because I have like 15 or more Chrome
Yeah,
open here. So
probably. Yeah. Okay. Look, when
uh,
you run ls dash l NuttX.bin, did you see a file similar to this one with
Yes, exactly the same.
exactly the same size?
Yes,
Oh, good.
same size.
Let's just wait, Rodrigo, to finish.
yeah,
Um, Alison, did you have some questions in the chat?
Not yet, Alan, but yeah, not yet.
Okay.
But if you can show us the menu config,
Mm-hmm.
just to confirm the board configuration,
Yeah,
maybe
I think it's a good idea while Rodrigo finish.
yes.
This is the menu config. From here we can configure all the features of NuttX. So if you enter inside, for example, uh, system type, we see information about the what devices we are selecting inside peripherals. For example, here we have uh, OTG that we don't need, we can disable it, the power and sysconfig, and the UART2. Okay. Um, if I disable, for example, these functions, the compilation will be fast and the binary file will be smaller. Um, and anything else?
Could you share the examples? Maybe you must have.
Yeah, good idea. For example, if you go here to application configuration, we have many applications, and here inside examples, we have many already existing examples to NuttX. For example, to accelerometers, to LED strip, LED uh, LED, RGB LEDs strip, audio, battery, calibration, camera, um, battery charge example, GSM modem, and chronometer example for STM32 Discover board. Cordic is a function uh, that exists in some STM32 boards to create how to say it's it has some trigonometric operations in the core automatically. DHCP server to share IP with other boards and um, many other
Alan,
examples.
maybe, sorry to interrupt you, Alan. Maybe you can select the Hello World example. It's nice to see that.
Yeah, I think
Or,
I think
yeah,
I can do it,
nice.
and I will compile again. This time I will compile with the dash J to go faster.
Okay.
Also, yeah, also I will disable the things I don't want to compile. For example, USB. Yeah, and let's see. Okay, Rodrigo, did you machine finish?
In fact, I have an error here.
Oh, can you please
Oh,
share your screen?
yeah. Let's go there. Okay. For sure, I did something wrong here. Trying to figure out. So this is the error. Can you see?
Oh, yes, I can see it.
So not sure. I'm trying to see which file I did this mistake. So
I see it. You have another slash after STM32. There's nothing there.
Yeah,
You
but
needed to do something.
this is supposed to be the name of the board. Uh,
Yeah.
I think yeah, I think it's not configuring the board name correctly. Please open your
okay.
config your boards kconfig cd boards. Okay,
Okay.
yeah,
ARM, right?
no, just here,
That's here.
yeah.
Okay. So
Show me
the
the kconfig. Okay, search
time for
for,
the
yeah, the name of the board.
STM32F401. Okay, so configure
Okay, this name is correct. The
next one. Okay,
next
next one. Uh,
STM32F. I see it already. You put nucleo in the name of the board.
oh, here. Sorry.
Yeah,
Yeah. Thanks. Okay, so one more. Yeah. So that's right.
yeah. Search again to the bottom, because in the bottom
Okay.
it could happen again. No, it's correct. Move to the app. Search again to return to the beginning, just to confirm in the image it was
Oops.
not.
Sorry. Sorry. Said this.
Just
The
undo it.
okay. So, okay, this one is right?
Yeah,
Okay.
just search again. Or, yeah, okay. Yeah, and again.
Okay.
Okay, return to beginning. That's correct. You can save and exit.
Okay. Let's go back. Did I need to configure again? Or
Yeah,
just make...
yeah, because it is not. It is in a messy way. So it's better to make this clean and
So,
configure and build again.
okay, so the score is 1 for me, 1 for you, and 0 for Luke, right? The
Yeah,
typos.
Luke didn't
So the
didn't do any mistake. Yeah.
okay,
Don't
so
say that, not yet.
so
Now we
let's
run
go
configure.
to...
Yeah.
Okay.
And because, okay, just press enter. And because we want to go faster, just type make space uh, dash J. Yeah. I think it will. No, you don't need to pass any number. Just let it
Okay.
use all the processing, all the all the existing processors. Okay, compiling. Okay, done.
Yeah.
Run ls, yeah, NuttX.bin. Yeah,
It's
it's the
like
same size. Okay, it's good.
okay.
I think now you and Luke, we need to install the this. Let me show here this application, the FU UTIOS. Run it and tell me if you have it, the FU UTIOS installed in your machine.
I don't have it. I need to install it. Just a second.
Yeah, please install the FU UTIOS. Rodrigo,
No, I don't have this.
please install as
So
well.
yeah, sure.
And we need to use this command to flash. I will copy it in the chat here. This is because we are not using uh, the ST-Link to program the board, right? I think you or Luke doesn't have the ST-Link, so we decide to use the DFU function of this microcontroller.
Yeah, I don't have the stealing.
No problem. I suppose it will work, and we'll see now. Don't worry. So
I need to have the board connected, right?
yeah, but I will show it in a minute. I will copy it
Did you
first.
pay?
Hmm?
Sorry, Alan. Did you paste the command in the chat?
I will
Please?
paste. I will paste. I'm
Okay, thank you.
stopping the sharing here. Just a second here in the chat. Okay, I just put it. If Lucas or Alison want to put it in the YouTube, maybe it could be useful for someone. I don't know.
Yes,
But
I will do that.
thank you. And now let's go back. Okay. So before running this command, we need to put this board here, in DFU mode. So to do that, okay, first let's confirm, Rodrigo and Luke, did you already install the DFU choose?
Yes.
Okay,
Yes.
perfect. And before running it, oops, before running it, we need to do this procedure. You press this button, the SW1. It's also
Sorry.
this in the middle of the board. There is a button called boot 0 or
Yeah.
SW1. Press
Okay.
it and keep pressed, and press and release the other button, the reset button. You can now release the reset and keep the other. Okay, and now you can release the boot 0, and we can see now if it was detected as STM32 bootloader. Please run sudo dmask to confirm that you have the STM32 bootloader.
So the procedure is to press the boot.
Press and hold the boot 0.
Okay.
Keep it hold.
Okay.
Press and release the reset button.
Okay. And then release the boot.
Yeah, and then you run sudo dmask, and you need to see this line here.
Yeah,
You see?
I'm seeing. Okay.
Okay,
It's
look
okay
as
for me.
well.
Yeah,
Oh, perfect.
the bootloader line, right?
Yeah, that one.
Okay.
Now we can run that line, DFU util. This line that we paste in the chat, and you see this progress bar. Okay.
Okay.
Okay, mine's finished.
Yeah. Now pay attention here on this LED. If everything works correctly, when I press and release reset, it turns on. Oh, it's a good signal. Now, how I know that NuttX is running on this board? We need to connect the USB serial that you have in in your bench. So sometimes I face issue with when I use the GND because we are connecting the same board, but in the same computer. But let's try with GND. The the TX the TXD pin from the USB serial, we need to connect to RX, to USART to RX. Okay, this one. So
And
I run sudo dmask. I confirm I have the USB converted TTY USB 0 enabled. So I confirm it is created inside dev TTY USB 0. Then I run minicom, sudo minicom, because it's supposed to be the first time I did it. I configure the serial device to TTY USB 0, the baud rate, and that is it. Now I exit, then I can reset the board and see the NuttX shell starting. If I type help or question mark, I see all the NuttX commands. For example, it's like Linux or Unix, cat, cd, cp, rmd, and many other commands. And also, as Alison suggested, I enabled the hello example. If I type hello, I see the hello world example. Okay, Rodrigo and Look, we are going to say something. Did you get the USB converter working?
Yes, Alan.
Mm-hmm.
And I can.
Your microphone is not helping again, but okay.
Okay.
And
Uh,
did you get the, the terminal?
yes, I just didn't enable the Hello World
Okay,
example,
no,
so
no problem.
that,
But if you
but
type uname dash A, you can see this the NuttX version, right? The NuttX,
yeah,
the name of the
yeah,
board.
that's
Oh, that is perfect. I think we complete our mission for today. I'm sorry for the 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 electricity breakout because unfortunately here sometimes it's happened because I live in an island um, compared to other places in Brazil. It's not so common to happen. In some places, yes, it's happened a lot, but for example, in Minas Gerais, CEMIG doesn't make it happen so easily. But okay. Any other questions, Alison
uh,
or Rodrigo? Rodrigo, you said you are going to ask something else.
so my microphone is okay now.
Yeah, I can listen you.
Okay. Now I replace for the. So what's the next? What's the plan for the next session?
Yeah, I think for today we did our initial goal, and as you
Okay.
see, this board that Lucas created has many features. So it has four LEDs, four buttons. The it has the uh, SD SD card connector. It has the RX 485. It had some analog input. Lucas, do you remember any other things that your board has? USB, right?
USB, DAC, uh, RS 485,
SD
uh,
card.
SD card.
SD card, temperature sensor I2C,
Nice. Yeah.
EEPROM I2C also, and GPIO to make interaction with the user for LEDs and for buttons.
Yeah. There are many features in this board that you plan uh, to implement later. Um, I think for the next section we can define what the most interesting things to see. For example, we can start with the buttons, LEDs, maybe USB and SD cards,
Temperature sensor, I think.
temperature sensors. There are many features. We just need
Yes.
to ask Rodrigo and Luke what you guys want to do the next, want to start next, for example, for the next sections.
I think it's up to you guys. Maybe we can discuss and then let the guys in the YouTube channel know in another post in the LinkedIn. But I'm open for any of the things you want to do.
Okay.
Yeah, me too. I'll buy the USB serial and try it later, so we
Yeah,
can continue later.
but congratulations. I think your board worked because you saw the LED turned on, right?
Yes, yes. I'm pretty sure it's working.
This
It's
one.
just missing the connector.
Yeah.
Alan, I don't know if the NuttX already had support for TMP75 temperature sensor.
What the? Please repeat the number. we can do it here. For example, I can say the number.
TNP 7575.
Yes, is the I2C temperature sensor, right?
Yes, I say this because we can next live put the I2C bus and the temperature sensor and also the EEPROM to work. I think that will be simple and it's interesting because all the users can see how the NuttX use devices, for example, temperature, how the NuttX handle EEPROM. I think that should be good next session.
Yeah, I agree. I just disable the camera of the board here because we I think we finished with the board test today. Yes, I think the temperature and the prong are nice. Uh, Maybe we can also start with the very basic, like the buttons, because they are also easy to do. And also, I just remember something. Remember that I said, oh, we are doing very complex things to copy the board this way. Um, the other option, if I remember correctly, we have other board with already the 80 megahertz configuration that with similar architecture that we can use. I think it was board, ARM, STM32. Um, let's see. Oh, sorry. Let's see here. Um, I think this one, for example, has the 8 megahertz crystal. No, this one. I think this one has, for example.
Yes, all Nucleo use an external clock or internal RC.
Yeah,
Need to be other.
yeah. But as you see, the F401 RE, it use, but it doesn't come. The crystal doesn't come solder in the board. So, uh, but here we have, for example, inside this STM32F11, we have only one file, board.h. It's similar like we did. And if we go here and look the board configuration, see, it is using the 8 megahertz crystal and using the external high-speed clock. That means the board crystal.
Perfect.
So instead of doing all that difficult steps that I show, we can just do it. Copy STM32F401E disco board, include board.h to our board STM32F41RS include, and now it replaced our board.h. We just need to change the name now here. And also here, of course, right? But yeah. That's it. And I can just compile again. and if I flash, it will already use the external crystal instead of the internal oscillator. Okay. Well, guys, I think we are done for today, and thank you very much. Uh, Thank you all for the great live, the great event. Uh, Thank you, Lucas, for creating this board. This is a really nice board. And yeah, if you want to say something about uh, this board, Lucas, or about.
No, just what I think that we can do with a lot of live sessions. It is complete all board support, and
Agree.
then I think that also it is interesting. We show to all the users how to create a correct patch to send it to the NuttX mainline. As
Yeah,
an example, to all the users understand all the rules, how the code need to be formatted. And I think that all the ecosystems to understand how I do to create official support some for some board or for some sensor.
I agree. I think the first step maybe in the next event should be create the paths and submit it to mainline. Okay, Rodrigo, what do you think? Is okay as well?
Yeah, sure. For me, it's okay. Yeah.
Okay, so maybe because you already face some issues, you are you are the lucky guy. You will be responsible to submit it to mainline. Okay, we'll
That's okay.
we'll guide you to do that.
Let's do that. That's okay.
Okay, so thank you, Alison, for helping with the YouTube and uh, interact with the people. Uh, I think there are many people there that I want to interact, but in this live session, I need to focus in getting the board working. So I hope next time I will have more time to interact with the many friends that are in the chat. So thank you, guys. Thank you, Luke. And yeah, you
Thank you.
you are the big winner because you didn't make any mistakes. The only mistake was not getting the USB serial, but it's okay. Don't you worry. And again,
I will buy it later. I'll see if I can find it.
yeah, it's very easy. Uh, any mall about makers or anything like that will have this board. Okay. Thank you, guys. See
Thank
you.
you.
Bye
Bye bye.
bye.
Thank you.
Thank
Bye
you.
bye.
Bye bye. Have a nice weekend.
You too. Nice weekend. Bye, guys.
Bye bye.